Hello, my name is Isaiah, and I'm just going to be explaining a couple of basic ballistic terms to help hopefully understand what a bullet's characteristics and how it performs based on weather, temperature, or even the curvature of the Earth. Okay. First one is trajectories and sights. Okay. Next, we'll go over gyroscopic drift, drag, the Magnus effect, the Coriolis, and the evotos effect, vertical angles, and then the transonic ballistic performance. First is the trajectory and sights. A bullet's trajectory is the curved path it follows, mainly because gravity pulls it downward while it's traveling forward. The sights, or whatever you might have, are aligned so that this curved trajectory intersects with the straight line of sight at whatever chosen distance it might be. So whenever you're shooting, your trajectory wants to line up with the line of sight to the point of aim. Next, we've got the gyroscopic drift. Because a bullet is spinning rapidly, it behaves like a gyroscope. Its spin stabilizes it in flight, and then it also causes subtle torques. When forces like drag or crosswind act on this, these little torques can result in like a gradual sideways deflection in the direction of spin. This is called a gyroscopic drift, or often called a spin drift. Over long distances, that small sideways shift can become even more noticeable the farther you get out, especially with right hand twist barrels pushing the drift to the right. Next, we've got drag. Drag is the resistance force that air exerts opposite to the motion of the object, slowing it down as it moves. For a projectile like a bullet, drag reduces both its speed and its effective range, making it lose energy more quickly than in like a vacuum or something like that. The amount of drag depends on a ton of different factors like air density, shape, aerodynamics, and the object's velocity, which is a lot of math. You can see right there in the blue, it's kind of going over without drag the max effective distance of a certain caliber versus the red is what happens with drag. Next, we've got the Magnus effect. When a spinning bullet kind of moves through air, the rotation changes the airflow around the projectile. So one side sees faster, more relative airflow, and the other side is a little bit slower, creating a pressure difference. That pressure difference produces a small sideways or vertical kind of force, which is called the Magnus force, which can make the bullet's path curve ever so slightly in the direction of the spin. In longer range shooting, this effect is usually compared with like gravity and drag, but it's measurable and can kind of mess you up at higher ranges. Next, we've got the Coriolis and the evotus. Um, Both the Coriolis and the evotus effect are critical considerations in a lot of long-range ballistics. The Coriolis effect primarily influences the horizontal deflection based on the Earth's rotation, while the evotus effect um, affects the vertical trajectory due to the changes in apparent weight during the eastward or westward motion. Understanding these effects is kind of essential for precision targeting over a lot farther distances. Next up, we've got the vertical angles. When shooting like uphill or downhill, a bullet's path is kind of affected by gravity acting on the horizontal distance, not necessarily the slope distance. This means even if you're on like a straight line distance to the target is long, you kind of have to aim lower than the line of sight for uphill or downhill shots, correctly kind of accounting for vertical angles, ensuring that the bullet hits the intended target despite whatever slope may be. Finally, we've got transonic ballistic performance. In this, transonic ballistic performance occurs when a projectile transitions through speeds near almost to the speed of sound, typically like a Mach 1. When airflow around the projectile becomes unstable, this transition can increase drag, turbulence, and slight trajectory deviations. Um, Extremely affecting accuracy and velocity and especially consistency, which is the hardest part. At the end of the day, we've covered trajectory and sights, gyroscopic drift, drag, Magnus effect, the Coriolis and the Evotos, vertical angles, and transonic ballistic performance. All of these are extremely important for um, anywhere from 100 out to 1,000 yards. Every single point is very important for you to understand and master. If you're interested in learning a little bit more about this, Liz B from Applied Ballistics makes some amazing articles, books, all that other stuff that explains um, all of the different amazing things within ballistics. Same with Ned Stowe. He does a lot of really good stuff on external ballistics. Thank you for watching.